Yes, good evening students. In the previous class, this is a continuation of the previous class. So there, this x inverse is 1 by 2a of this matrix, and this 2a stands for the a stands for the area of the a triangular element. Hence, this 2a becomes the determinant of this value. And here, what is this alpha I, alpha j, alpha m? That we have shortly we have denoted this, because after finding the x inverse, see here this x stands for 1 ri zi, 1 rj zj, 1 rm zm. This x, when you find the inverse, it yields this one, where this alpha I, alpha j, alpha m, beta I, beta j, beta m, gamma I, gamma j, gamma m, all are similar to this x and y in CST element. See, you just take this order I, j, m. I, j, m. You should not reverse this order. So when it is alpha I, it would be r, j, z, m. Minus, you just reverse this order. So what you will get? Z, j, r, m. Similarly, alpha j means after j you have m and then only I. So rm is at I minus, you just reverse the order and the variable. Similarly m, so after m you have I and j, so ri is j minus zj ri. Similarly here, this beta and gamma, it involves only individual coordinates. So beta stands for the difference between the z coordinates, difference in the z coordinates, and gamma stands for difference in the radial coordinates. So here I, j, m, j, m, I, m, I, j. In finding this gamma 1, you are going to replace this z by r, and also you are going to reverse this order. Here zj minus zm, rm minus rj. Here zm minus zj, here ri minus rm. That's it. So this also we have already explained in the CST element. The same procedure you just follow here also. Only thing is you are going to replace the x and y by r and z. So this is how we arrive this a1, a2, a3, a4, a5, a6, and finally you have to combine these two matrices. Before that, see what is u at r comma z, that is a1 plus a2r plus a3 z. That expression alone I am writing at an that is a matrix form as 1r z into a1, a2, a3. So now what you have found out, the value for a2, a3, that you are going to substitute here, and the 1 by 2a I am taking out, and this is what the expression for this. So here when you multiply these two, alpha I u1, alpha j into uj plus alpha m to um, similarly this one. So finally what I am getting is like this. And after that again you multiply this 1rz, these two matrices, so that you will get this one. So now similarly this is for u or u of r comma z. Similarly for w, you can take the expression for this a4, a5, a6 in the w, and you just do as like we did for u. So finally what we are arriving here is, we are arriving the safe functions, that is ni, nj, which represents 1 by 2a alpha I plus beta I r plus gamma I z. Nj is 1 by 2a alpha j plus beta j r plus gamma j I z. Similarly for nm, it would be 1 by 2a alpha m plus beta m r plus gamma m I z. So these three denotes the safe functions of the axisymmetric elements. Yes, so this is what ni, nj, nm. So these three represents the safe functions of the axisymmetric elements. Now coming to the general displacement at each node. See, this xi I denotes both the nodal displacements along the radial direction and also the z direction, that is longitudinal direction. So in terms of safe functions, we can write, suppose say in a one-dimensional element having two nodes, if u1 and u2 are the nodal displacements, how we can write this general expression for the displacement at that particular node as u1 n1 u1 plus n2 u2, that is equal to u. Similarly here, this is n1 ni ui plus nj uj plus nm um. Similarly for w, it is ni wi plus nj wj plus nm wm. Now we are going to write this in matrix form as shown below. So we will stop up to this and we will continue in the next class.